Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. Let us solve some more questions on the chapter of circles. Now this exercise may be known as optional exercise and it may not be that important from the examination point of view for your class 9th. However, it is really important from the conceptual clarity point of view, right? So it will clear your concepts in more depth, right? So let us do these questions. Prove that the line of centers of two intersecting circles, that is line joining the centers of two intersecting circles, subtends equal angles at 2 points of intersection. So let us draw two intersecting circles first. Okay, A and B are the 2 points of intersection, and let the center of this circle is O and center of this circle is O dash, and the line joining the centers is O dash. Okay, now this line O dash subtends this angle at point A and it subtends an angle at point B. So we are talking about these two angles here. Okay, so we need to prove that these two angles are equal. So if you observe these two triangles in triangle AOO dash and BOO dash, you will observe that OA is equal to OB because these are radii of the same circle. So I can say AO is equal to BO because these are radii of same circle, hence these are equal, right? Similarly, you can say that AO dash is equal to BO dash, radii of same circle, that is this circle. Okay, now the third side in these two triangles is OO dash. So OO dash is equal to OO dash because it is common side to both the triangles that I am talking about. Hence, by side congruence criterion, what can I say about these two triangles? These two triangles are congruent to each other. Triangle AOO dash is congruent to triangle BOO dash, right? If this much is clear, now you can say that this angle, that is angle A, is equal to this angle, angle B, because of CPCT by CPCT. What is CPCT? That corresponding parts of congruent triangles are equal. So these angles are corresponding parts of two congruent triangles, hence they are equal. So I will say hence it is proved. Let's move to the next question. So if your concepts are clear, then these questions will look easy to you. In this question, two chords AB and CD of lengths 5 cm and 11 cm respectively of a circle are parallel to each other and are on opposite side of its center. So if I draw this figure, it will be something like this. This is my 5 cm chord AB and let it be 11 cm chord CD. Okay, and this is the center, right? And these chords are parallel to each other. This one is 5 cm and this one is 11 cm. So if the distance between AB and CD is 6 cm, so let me draw a line passing through the center which is perpendicular to both the lines. So if a line is perpendicular to this chord, it will automatically be perpendicular to this chord because these are parallel chords. So anyways, this angle is also 90 degrees, and this being center, and let it be OM and ON. OM being the perpendicular on chord AB, it will bisect the chord AB. So this segment MB will be half of AB, that is 5 by 2 centimeter. Similarly, I can say that this segment ND will be 11 by 2 centimeter. Okay. Find the radius of the circle. So we need to find the radius, which is this OB. If I join, this will be my radius, and OD is also the radius. So I need to find R in this question, right? So let me say that this segment ON is x centimeter. If it is x, can someone tell me what will be the length of OM? The distance between these two chords is 6 centimeter. So if ON is assumed as x centimeter, then OM will be 6 minus x centimeter, right? So what I have assumed is, let ON is equal to x centimeter. This will imply that OM is equal to 6 minus x centimeter. Okay. Now look at these two right angle triangles. In right angle triangle OMB, I can apply Pythagoras theorem. So OB square, that is R square, will be equal to 6 minus x squared plus 5 by 2 squared. I have just applied the Pythagoras theorem. Let me simplify it further. So if I open this, it will be 36 plus x square minus 12x plus this will be 25 by 4. Okay, let it be my equation number 1. Okay, similarly I can get value of r square using this triangle. So applying Pythagoras theorem in right angle triangle OND, I can say r square will be equal to x square plus 11 by 2 squared, that is x square plus 121 by 4, and let it be my equation number 2. Now in this question I need value of the radius. So essentially I need to eliminate x using these two equations. Okay, this is one of the way of thinking about it. Other ways, if I can obtain value of x using these two equations, I can simply put it back in any of these two equations to obtain value of r, right? So it is easier for me to eliminate r square in these because I have got r square on left hand side of both the equations. So I am simply comparing these two equations, so I can write this expression is equal to this expression because their left hand sides are r square. So 36 plus x square minus 12x plus 25 by 4 is equal to x square plus 121 by 4. Now x square can easily be cancelled here. If I bring 12x on the right hand side, this 121 by 4 will come on the left hand side and this 36 will remain as it is. Now let us see, 36 plus, this is 121 by 4 is with a negative sign, so 25 minus 121 is negative 96, so minus 96 by 4 will be here. Okay, so it is equal to 12x. Now this plus sign will become negative 36 minus 96 by 4. What is this? 4 2s are 8, 4 4s are 16, so it is 24. Okay, and it is equal to 12x. So this is 12 and it is equal to 12x, so it will give me x equal to 1. Now if I replace value of x in any of these equations, I will get r square easily. R square is equal to 1 square, that is 1, plus 121 by 4, so which is equal to 4 plus 121 by 4, 125 by 4. So r is equal to square root of 125 by 4, that is denominator I will get 2. In the numerator 125 is nothing but 5 into 5 into 5. So it will give me 5 root 5 here. Okay. So r is equal to 5 into, this is 2.2 approximately, let us say, by 2. So it will be 5 into 2.2 will be something close to 11. 11 by 2 will be approximately 5.5. So the radius here is 5.5. 5 centimeter approximately. This is the approximate calculation here. If lengths of two parallel chords of a circle are 6 centimeter and 8 centimeter, if the length of smaller chord is at distance 4 centimeter from the center, what is the distance of other chord from the center? This question is very simple if you have been listening to my lectures carefully. We have got two parallel chords, one is of 6 centimeter, second is of 8 centimeter length. So let it be 6 centimeter length and this be 8 centimeter length. Smaller chord is at a distance of 4 centimeter from the center. So let us say this distance here is 4 centimeter. When I say distance, I mean perpendicular distance. So this is perpendicular to it. And if I drop a perpendicular from the center to any chord, it bisects the chord. So if I denote it by M and let it be AB, what will be MB? It will be half of AB, that is 3 centimeter, right? And I need to find this distance here, ON, right? I need to find ON. Now this question is a 10-second question for you. If you have been listening to me, 3, 4, 5, these are numbers which have a special characteristic. That is that if there is a triangle with dimensions 3, 4 and 5. So if this is 5, this is 3, this will be 4. This is about a right angle triangle and these are Pythagorean triplets. I have been saying it repeatedly that if you square 3 and add the square of 4 in it, you will get 5 square. That is 3 square plus 4 square is 5 square. So these numbers satisfy the Pythagoras theorem. So if I am given 5 and 4 as two sides, where 5 is hypotenuse, then I can say the third side is 3. If I got 5 and 3 as two sides and I know that 5 is opposite 90 degree, then I can say simply the third side is 4. If I get 3 and 4 as two sides of a triangle and I know the angle between them is 90 degrees, then I can directly say that the third side is 5 centimeter. Look at this question. If I join OB, it is opposite this angle 90 degrees. So what will be length of OB? It will be 5 centimeter. Otherwise, what you can do is you can apply Pythagoras theorem and check for yourself. So if OB is 5 centimeter, what will be OD? It will also be 5 centimeter. Why? Because it is also a radius of this circle. And what will be ND? It is half of 8, that is 4. Why? Because it is perpendicular from this center to chord CD. So it will bisect the chord CD. Hence this portion ND is equal to 4 centimeter. Now look at this. If this is 5, this is 4, what will be this length? This length will be 3 centimeter. So your answer of this question is 3 centimeter. Okay, although it is not from the examination point of view, but if you want to write it in some examination, what you can do is you can make a statement first. If you drop a perpendicular from the center of a circle to a chord, it bisects the chord. So you can say OM is perpendicular to AB, hence MB is half of AB, right? Hence equal to 3 centimeter. Now that you have got MB, so you can apply Pythagoras theorem. Applying Pythagoras theorem in triangle OMB. Now you can say OB square is equal to OM square plus MB square. Hence you will obtain that 3 square plus 4 square, it is equal to 25. And now you will obtain the radius of this circle, that is OB, equals 5 centimeter. So if OB is 5 centimeter, this would imply that OD is also 5 centimeter, right? And ON being perpendicular to CD, this would imply ND is half of CD, that is equal to 4 centimeter. Now again you apply Pythagoras theorem in this triangle. By Pythagoras theorem in triangle OND, now you can say that ND square plus ON square is equal to OD square. You know it is 5, you know ND is 4, so ND square is 4 square. ON square you can obtain easily from it. ON square will be equal to 25 minus 16, that is 9. So ON will be 3 centimeter and it is your answer. Okay. Otherwise, just by looking at this figure, you could have said that this length is 3 centimeter. Let the vertex of a triangle ABC be located outside a circle and let the sides of the triangle intersect equal chords AD and CE with the circle. Prove that angle ABC is equal to half the difference of angles subtended by the chords AC and DE at the center. So let me draw the figure for you, then you will understand this question better. There is this triangle, one of the vertices is outside the circle and there are two vertices which are on the circle. So this vertex that is outside the circle is B and this is A, this is C. So AD and CE are two chords of the circle and let AD subtends an angle like this, okay, and CE also subtends an angle at the center, okay. Prove that angle ABC, that is this angle, let it be angle beta. Prove that angle beta is equal to half the difference of angles subtended by the chords AC and DE at the center. This is chord DE. So let us say angle subtended by chord AC is theta and angle subtended by chord DE is alpha. So what we need to show here is beta is equal to theta minus alpha by 2, half the difference of angle subtended by chord AC and DE. I hope the question is clear to you now. This is what we need to prove. Okay. Now look at this. There is a little construction. If I join A with E, okay, if I join A with E, now look at this chord DE. Chord DE subtends angle alpha at the center of this circle. Chord DE subtends angle alpha at the center of this circle. So what will be this angle? What will be this angle? Let me change the color. This angle will be half of angle subtended at the center by chord DE, because this is the angle subtended by chord DE at the rest of the circle, remaining part of the circle, right? So it will be half of angle subtended at the center. So this angle will be alpha by 2. Okay, this is about one of the angles. Now let us look at this chord AC. AC subtends angle theta at the center, and AC also subtends this angle at the circle at point E. So this angle will be half of angle theta, because of the property that the angle subtended by a chord at the center of the circle is double the angle subtended by the same chord at the remaining part of the circle. Okay, so this will be theta by 2. Now in triangle BAE, if you look, theta by 2, this angle is an exterior angle of this triangle BEA. So theta by 2 is equal to sum of interior opposite angles. So beta plus alpha by 2. Theta by 2 is equal to beta plus alpha by 2. Hence you can say beta is equal to theta by 2 minus alpha by 2, that is theta minus alpha by 2. Hence proved. Now I am not writing all these steps in details because this is anyway above your level of examination, and this is for your understanding. Once you understand this, you can write the steps yourself, that this exterior angle of a triangle is sum of the interior opposite angles, right? This statement you can write here. Other statement that you required in this question was that angle subtended at the center is double of the angle subtended at the remaining part of the circle. Okay, so using these two statements you can easily prove this question. Prove that the circle drawn with any side of a rhombus as diameter passes through the point of intersection of its diagonal. So if I take a rhombus and think about its diagonals, the diagonals of a rhombus intersect at 90 degrees. So first statement, diagonals of a rhombus intersect at 90 degrees. This is the property of a rhombus. Now look at this. If I take any side of the rhombus as diameter, let us say this is rhombus ABCD, and I take this side AB as the diameter. So if I take AB as diameter, where will the circle pass from? Will it pass through this point of intersection of diagonals necessarily or not? It will definitely pass through this point. Why? Because this angle is 90 degrees, and if we are taking AB as diameter, then this angle will also be an angle in the semicircle, so which is anyway 90 degrees. Hence it is necessary for the circle to pass through this point of intersection of diagonals. So what you can do here is, you can make this statement diagonals of a rhombus intersect at 90 degrees. If we take any side, let us say AB, as diameter and draw a circle, it will pass through O. Why? Because angle in a semicircle has to be equal to 90 degrees, right? So, and all the points that satisfy this condition, let us say this is the point, this is some other point. If you join A and B with this point, that angle will also be 90 degrees. So all the points at which, let us say I have got this diameter AB and I have got this point, okay, for which this angle is 90 degrees, right? I have got another point for which the angle is 90 degrees. So it is necessary that these points will be part of this semicircle for which AB is a diameter, right? Hence it will definitely pass through O. Other way of showing it is, see, if I draw these lines, this line is parallel to these lines, right? And another line which is parallel to these lines. Okay, rhombus is also a parallelogram. So I have drawn two lines, this one and this one, which are parallel to the pair of parallel lines. Okay, so now if I can somehow show that these distances, this is the center of the circle, this is half of the side AB, so this is the center. Now if I can show that this distance is equal to this distance, which is anyways equal, is equal to this distance, then it will be clear that this point is equidistant from O, A and B, hence it will necessarily pass through O. Okay, so if I can show that this distance is equal to these distances, then it will be clear. Now see, when I draw this line parallel to this line and this line parallel to this line, AMON will also be a parallelogram. AMON will also be a parallelogram. AM parallelogram, because of the construction, because I have drawn OM parallel to AN and ON parallel to AM. Now one of these angles, one of the angles of this parallelogram is 90 degrees. One of the angles is equal to 90 degrees. Hence AMON is a rectangle, right? Okay. Now AMON is a rectangle. This is one thing. Second thing, that it is a rhombus. So all its sides are equal. So their halves will also be equal. So AM will also be equal to AN, which happen to be the halves of equal sides. So now if adjacent sides of a rectangle are equal, it is a square. So AMON, adjacent sides of AMON being equal, it is a square. So if AMON is a square, then we can say that AM is equal to OM. So AM is equal to OM, hence it is equal to NB. So the circle necessarily passes through O. Okay, so how did I prove that this is a square? By showing that AB is equal to AD, and I have taken halves of AB and AD as AN and AM. So these sides became equal, hence this quadrilateral AMON became a square. Okay, right. If ABCD is a parallelogram, the circle through A, B and C intersect CD produced if necessary at E. Prove that AE is equal to AD. Let me first draw the diagram, then the question will be clear to me. This is a parallelogram, A, B, C and D. Circle through A, B and C. Let us say this is circle which passes through A, B and C, and it intersects CD at E. So if I produce CD, it intersects at E. Okay, so now if I join this A and E, now this A, B, C, E is a cyclic quadrilateral, and especially it is a trapezium, because it has got two parallel sides and two non-parallel sides now, right? So we will use two properties, that it is cyclic. So this angle here, angle E and angle B, sum of these angles is equal to 180 degrees, right? And another property that I am going to use here is of the parallelogram. So this angle here, angle D is equal to angle B, because opposite angles of parallelogram, right? So now look at this. If you consider this angle as theta and this angle as, let us say, alpha, and this angle E as angle beta. Okay, so what can you say about these angles? Alpha is equal to angle B plus, let us give a name to this angle also, gamma. So now beta plus gamma is equal to 180 degrees. Alpha is equal to gamma. So from here I can say, I can replace gamma by alpha. So alpha plus beta is also equal to 180 degrees. But look at theta and alpha. Theta and alpha are linear pair. So I can replace alpha by 180 minus theta, right? So let me do that. Alpha is replaced by 180 minus theta plus beta is equal to 180. So 180 will get cancelled and beta will be equal to theta. This was the purpose of this exercise here, that I wanted to prove this angle equal to this angle here. Now if these two angles are equal, this triangle becomes an isosceles triangle. So the opposite sides to equal angles are also equal. So AE is equal to AD, right? So it can be easily proved. Now if this was the case in which we had to produce CD, there can be another case like this. A, B, C, D. Let us say we draw a circle passing through A, B and C. This passes through C, okay, and it intersects CD at E, okay. In this case, if I join AE, now see this angle, let us say is theta, so this angle will also be theta, and this angle here will be 180 minus theta. Why? Because if this angle is theta, this angle is supplementary to this, because ABCE is a cyclic quadrilateral, so this angle will become 180 minus theta, right? And if it is 180 minus theta, what will be this angle? This angle will again become theta, because it is a linear pair to this angle. Now in this triangle, again the angle, two angles are equal, so sides opposite to equal angles are equal. I hope this question is clear to you. Now you can write the steps yourself, because this is an exercise to strengthen the concepts, okay. We do not want to write each and every step and waste our time, okay. This is just for our understanding. AC and BD are chords of a circle which bisect each other. Prove that AC and BD are diameters and ABCD is a rectangle. So what is given in this question is, AB and CD are chords of a circle which bisect each other. That means this portion is equal to this portion and this segment is equal to this segment. If this is, let us say, AC, this is BD, okay. So let me remind you one thing about parallelograms. In a parallelogram, the diagonals bisect each other. So whenever I see two lines bisecting each other, I somehow, it gets to me that there may be a parallelogram somewhere. So if I join AB, BC, CD and DA, what will be ABCD? ABCD is a parallelogram. Why? Because if in a quadrilateral we can prove that its diagonals bisect each other, then it is enough for us to say, that this quadrilateral is a parallelogram. So if the diagonals of any quadrilateral bisect each other, then this quadrilateral is nothing but a parallelogram. So ABCD is a parallelogram because its diagonals AC and BD bisect each other, right? So ABCD is a parallelogram. Now AC and BD are diameters. This is what we need to prove. Look, if ABCD is a parallelogram, number one thing. Second thing is that ABCD is a cyclic quadrilateral, or you can say a cyclic parallelogram. What is the beauty of a cyclic parallelogram? Let me tell you by comparing these. Angle B plus angle D, can you tell me their sum? Their sum will be equal to 180 degrees. Why? Because it is cyclic, and opposite angles of a cyclic quadrilateral are supplementary. Now it is a parallelogram, so angle B will be equal to angle D, right? So from here you can say angle B equal to angle D is equal to 90 degrees. So both of these angles are 90 degrees each. Similarly, these angles are also 90 degrees. Now in a parallelogram, if only one of the angles is proved to be 90 degrees, it becomes a rectangle. So from here I can say ABCD is a rectangle. How did I arrive at this result from this result? By looking at these angles. Okay, so ABCD is a rectangle. Now if ABCD is a rectangle, look at this angle. Angle B is 90 degrees. That means AC is the diameter, because in a circle, in a semicircle, the angle is a right angle. So what does it mean? That this side is the diameter. So how would you write this statement? Angle B is equal to 90 degrees. This means AC is a diameter of the circle, because it is angle made in a semicircle which can be 90 degrees. Okay. Similarly, you can say BD is a diameter because angle C is 90 degrees. I hope this part is clear. And second part, I have already proved that ABCD is a rectangle. So this question should be clear to you by now. Bisectors of angle ABC of a triangle ABC intersects its circumcircle at D, E and F. Prove that. Let us first of all draw the figure so that the question is clear to us. There is this circle and there are 3 points A, B and C on this circle. A, B, C. Bisectors of angle A, B and C. So if I draw a bisector of angle A, and bisectors of angles of a triangle pass through a same point, right? What is this point? This point is also known as in center of the circle. When angular bisectors intersect at a point, this point is also known as in center. So now we are not interested in this point, but we are interested in these points D, E and F. So bisector of angle A intersect the circle at D, bisector of angle B at E and bisector of angle C at F. Prove that the angles of triangle DEF are 90 minus half of A, 90 minus half of B and 90 minus half of C. Okay. Let us look at these angles. What is this angle? This is half of A. This is also half of A, because AD is the angular bisector. So this is half of B. This is also half of B. I am writing these so that the question becomes really clear to you in your mind. And once the question is clear, the answer will come in 5-10 seconds. Okay. So these are half of angle A, half of angle B and half of angle C. And we are talking about angles of triangle DEF. So first of all, let us complete the triangle DEF. Okay. Now that the triangle is completed, I need to prove that this angle here is 90 minus half of angle A. Okay. Now focus your attention here at this arc BD. This arc BD forms an angle or subtends an angle at this point A, which is equal to angle A by 2, right? This arc BD subtends this angle here. angle A by 2. And what other angle it subtends? It subtends another angle, that is this angle, right, on the same segment of the circle. Okay. Now look at this part of the angle E. I am focusing on angle E now. This part of the angle E is equal to this angle, half of A, and this part of angle E, which is subtended by this arc FB, is equal to half of angle C, that is this angle, because arc FB subtends this angle C by 2 at point C, and this angle, let us say angle 1, at this point E, right. Now what can I say about angle E? It is equal to angle C by 2, because this part is equal to angle C by 2, and if it is 2, it is equal to, the part 2 is equal to half of angle A. So it is half of angle A. Angle C by 2 is nothing but equal to angle 1 because of chord FB, right, and angle A by 2 is equal to angle 2 because of chord BD, right. This is the reason. So angle E is equal to half of angle C plus half of angle A. Now I know that angle A plus angle B plus angle C is equal to 180. So their halves, if I can divide both sides by 2. So half of angle A plus half of angle C plus half of angle B is equal to 90. So what is this? Half of angle A plus half of angle C. It is equal to 90 minus angle B by 2. So what is angle E? It is equal to 90 minus half of angle B. And this is what I had to prove, that angle E is equal to 90 minus half of angle B, right. This is first thing that I have proved. Similarly, I can prove other angles to be 90 minus half of A, 90 minus half of C. Let me change the color and do this for you. So now if you consider this part of angle D as 3, this part of angle D as 4. Okay, so for angle 3, I will focus on this arc AF, right. Angle 3 is subtended by arc AF, and which other angle is subtended by arc AF? This angle, angle C by 2. So I can say angle 3 is equal to angle C by 2. Okay, and when I need to talk about angle 4, I will focus on arc AE. So arc AE subtends angle 4 at point D, and arc AE subtends angle B by 2 at point B. So angle 4 is equal to angle B by 2. Hence, if I add these two, I can say angle D is equal to angle C by 2 plus angle B by 2, hence equal to 90 minus angle A by 2, after you consider this equation here, right. Similarly, about the third angle, now which angle is left? This one. So if I consider this as angle 5, let us say, and this as angle 6. So for angle 5, I will look at this arc EC. Arc EC subtends angle 5 at point F, and angle EC subtends angle B by 2 at point B. So angle 5 is equal to angle B by 2, because angle subtended by the same arc at the same segment of the circle. Okay, now which part is left? Angle 5 I have already considered. Now I will take angle 6. Angle 6 is subtended by arc CD at point F, and which other angle is subtended by arc CD in the same segment? Angle A by 2. So angle 6 is equal to angle A by 2. You can give the reasons yourself. What is the sum of angle 5 and angle 6? It is angle F. So angle F is equal to angle A by 2 plus angle B by 2, hence is equal to 90 minus angle C by 2. Two congruent circles intersect each other at points A and B. Through A, any line segment PAQ is drawn so that PQ lie on two circles. Now these are two congruent circles. Okay, so congruent circles means circles of the same radii. Okay, their radius is equal. So these are two congruent circles and these intersect each other at A and B. Through A, any line segment PAQ is drawn so that PQ lie on two circles. So let me draw this line here, PAQ. Okay, prove that BP is equal to BQ. What is BP? This is BP and this is BQ. Okay, so I need to prove BP equal to BQ. So if I can prove that this angle is equal to this angle, I can say that triangle BPQ is isosceles, so their opposite sides of equal angles are equal. So BP will be equal to BQ. Okay, now look at this. This is common chord. Okay, this is the common chord. So now look at these two circles. These are congruent circles. Number one thing, congruent circles. Let us say I talk about these congruent circles. If I know that this chord is equal to this chord, right? So in congruent circles, the angle subtended by equal chords is equal. If this is theta, this will also be theta. This is the concept that we have already covered in our previous lectures. Now look at these two congruent circles. This chord AB is common to both the circles. Okay, hence this chord AB, if it is subtends an angle theta here, it will subtend the same angle theta here, right? The reason is that in congruent circles, angle subtended by equal chords, is equal. So this is the reason, and because of this reason I can say that this angle is theta, so this angle will also be theta. Hence it became an isosceles triangle. So triangle BPQ is isosceles with equal sides as BP and BQ, and this is what we had to prove. In any triangle ABC, if the angular bisector of angle A and perpendicular bisector of BC intersect, prove that they intersect on the semicircle of triangle ABC. So let us make a circle first and a triangle ABC. Why do I draw such big diagrams? Because then it is easier for me to visualize the question. So I recommend in geometry you draw bigger diagrams. Okay, if angular bisector of angle A, let it be A, B, C. So angular bisector of angle A, it means if this is alpha, this will also be alpha. Okay, and perpendicular bisector of BC. So perpendicular bisector of BC, they intersect at the circumcircle. This is what we need to prove, right? So let this point be M. Now how can I prove it? Let us say this AD is angular bisector of angle A, okay, and DM is a median, or DM divides side BC into two equal parts. BM is equal to MC. So what I have assumed here is AD is angle bisector, okay, DM, or you can say DM is perpendicular to BC. You can always draw DM perpendicular to BC. So these are the two things that I have drawn. Now if I can prove, if I prove BM equal to MC, then it will be sure that DM is perpendicular bisector of BC, right? Now to prove this question, what I have done here is I have taken AD as angular bisector of A, which I can easily take, which is allowed, right? Now from point D, I am dropping a perpendicular on BC. If this perpendicular divides BC into two equal parts, then this statement will be true. Okay, so I just have to prove that BM is equal to MC, right? And this is perpendicular here. So now if I join DC and BD, what can you say about these two chords, right? This is what we need to prove. This is not equal, right? So if this is M, I need to prove BM equal to MC. Okay, now if I draw these two chords BD and DC, will they be equal? Yes, because these subtend equal angles at point A. So chord BD is equal to chord DC. Okay, now in triangle BMD and triangle CMD, we have taken this angle M as 90 degrees. So BD is equal to CD because equal chords, right? MD is equal to MD, common to both triangles, and angle M is equal to angle M, 90 degrees each, right? Because we have taken it so. Now by RHS congruence rule, these two triangles, triangle BMD and triangle CMD, are congruent triangles, and if these are congruent, then BM will be equal to CM by CPCT. So we showed that if we drop a perpendicular from D to side BC, it will bisect this side BC. Hence we can surely say that angular bisector of angle A and perpendicular bisector of side BC intersect at the circumcircle, that is at point D. Another thing that you could have, another way that you could have proved it, you could have imagined that you take a bisector of this side BC. Okay, if you join D with side BC, you could have assumed it to be the bisector, and then you could have proved that this angle is 90 degrees. This was another way of proving it, and that is equally easy. Okay, so you can go by any of the two ways, but it is always recommended that you drop a perpendicular from D to BC, because we can do that easily. Otherwise, if we drop a median to, let us say, BC from D, it is not like it will not be easy for us to draw the median, right? But anyways, we can drop a perpendicular. Alright, so this was about this exercise. I hope you will find this exercise interesting, because you will need a lot of conceptual clarity to do this exercise, and if you do this once, your concepts will anyways be clear. Thank you.